Welcome to the 9.4 video about trigonomic equations. So first thing we're going to do is determine whether a given number is a solution of the equation. So considering sine x plus cosine x equals 1, is pi over 4 a solution? Is pi over 2 a solution? Well, the only thing we need to do is plug in and see if it's true. So if I do sine of pi over 4 plus cosine of pi over 4, my question is, does it equal 1? Well, I know sine of pi over 4 is root 2 over 2. Cosine is actually the same thing. So already I'm like, okay, add these together, that's root 2. That is not true. So all I have to say is pi over 4 is not a solution. Okay, let's try my other one. Is pi over 2 a solution? Again, plug in. And ask yourself if it's true. Well, sine of pi over 2, is 1. Cosine of pi over 2 is 0. So indeed, 1 equals 1. So pi over 2 is a solution. Okay, simple as that, just making sure we can plug in information. Now moving on a little bit, huge announcement. On your homework, it's going to tell you to find all possible angles. I want to cut that. I want it to be between 0 and 2 pi. So one full rotation on the unit circle, because if you can find those, then all the rest apply. So please just focus on 0 to 2 pi. It will save yourself a lot of time. So, a couple examples. Let's consider the equation sine of x equals 1/2. Find all the solutions on this interval. Again, don't go crazy. I just want one interval. Well, I'm going to draw a picture because that helps me. I know sine is 1/2 and sine is positive. So thinking of all students take calc, I know it's going to be in these two quadrants, the first and the second. Now, if sine is 1/2, that means this is 1 over 2. This is 1 over 2. I know, based on all my unit circle work, that the angle in between is actually going to be pi over 6. Okay, that should be known. Or you can say 30 degrees. But because we're here talking about pi, we are going to stay in radians. Well, let's find the angles that match this. Well, the first angle is pretty easy. Here to here, so pi over 6. The next angle will always start on the x-axis, head over to here. So that's pi 6 less than pi, because you know pi is on that 180 degrees. So that would be 5 pi over 6. And now my question is, can I keep going? Can I actually do here all the way around and come back up and land here? So technically that is 13 pi over 6. Well, the reason I can't do that, it's not in my interval. I have to end at 2 pi. Well, 13 pi over 6 is over 2 pi. So this one's not applicable, and you can just write not in restriction. Okay, so just be aware I only want from 0 to 2 pi, so one revolution. Now, let's use our calculator to make sure we found all the potential solutions. So, on our calculator, there's a couple buttons we need to use. We're starting out with sine of x equals 1/2. Now, we have talked about this before, but I want to undo sine. So I'm undoing a trig function. How you do that is by introducing sine inverse. Well, the sine inverse, if you do it on one side, make sure you do it on the other. Kind of the algebra behind it. Now this button, if you don't know how to find this button, I'm going to put a little arrow. The button, you're going to press second. Press the sine button because that introduces the sine inverse. You write in what our degree is, and then you press enter. So this button is just pressing the second button before you press your trig function. Now the reason why I do this is because these undo, they cancel out, so all I'm left with is x equals the sine inverse of 1/2. If I type that in my calculator, you should get 0.524, which is approximately pi over 6. So look at that. Check, check. I found my first angle. So here is my first angle. Now, the calculator will only give you one. What kind of stinks is you now need to find your other angle. So I'm going to write need to find next angle, however you want to write it. Okay? Well, how you do that is you think about your unit circle, you think about what quadrant sine is going to be positive, and I notice over here, I'm really like, okay, I'm at sine of pi. I need to take away pi 6 to get to that angle. So I'm going to go with, okay, I'm at pi. If I take away that angle I just found, I get about 2.62. Well, quick check, let me plug in. That is 5 pi over 6. Check and check. Okay, so you need to know what quadrant in order to find what value you're using here. It might be pi, it might be 2 pi, it might be pi halves, like just depending on what quadrant you're in. We'll do many examples, but again, if you can do it in part A, part B is just reiterating, making sure you found the right information. Okay, let's do one more. Now we're talking about where sine is negative. So just like before, I'm going to draw my picture. Sine is negative, so now I'm not in the first and second quadrant anymore. I'm actually in the third and fourth quadrant, just based on the fact that sine is negative. This would be negative root 3 over 2, same thing here. With all my work on unit circle, it's clear to me that these angles will be pi over 3 or 60 degrees, but again, because I have this pi here in my interval, I know I am in radian. So let's find these measures, again sticking in between 0 and 2 pi. Well, I need to start at this axis, so I head over to here. This is my first angle, which would be 4 pi over 3. Then I would again start at the same spot, go all the way around and here. So I'm pi thirds away from 2 pi, so I would have 5 pi over 3. So those are the only ones in my interval. Remember, I can only go 2 pi, so no more revolutions are possible. Now let's use our calculator and see how we did. So I am doing sine of theta equals negative root 3 over 2. I want to undo sine. So again, I'm going to use my sine inverse key. If you use it on one side, you need to use it on the other. The reason why I do this is because I'm undoing my trig function there, because I want to get the angle by itself. So say adios, adios. So my angle of sine inverse negative root 3 over 2. You should be getting about negative 1.05. Now, using my calculator, I can see this is really negative pi over 3. Well, that should bring up some questions, because that's not my two angles I found above. Well, think about it. This is not in the restriction. This is a negative angle. I am going between 0 and 2 pi. I can't have a negative angle. That is just telling me what the measure of my reference angle is going to be. So don't get confused by that. I need my answers to match part A. So I know that doesn't make any sense because it's not in the restriction. So instead, let me look at where I'm at. This really, my first angle is 4 pi over 3. Well, 4 pi over 3 is really pi plus that angle. So I'm going to do the same thing here. I'm going to do pi plus my angle of 1.05. That equals 4.19. That definitely equals 4 pi over 3. So this is my first angle. I check it here and here. Well, my next angle, I could look at it as, oh, it's 2 pi, but it's pi thirds short, right? It doesn't get fully around that rotation. So my other angle I'm going to find is 2 pi. Now I'm going to subtract my reference angle of 1.05. So that's 5.23. If I use my calculator to check, indeed, 5 pi over 3, check and check. So please make sure when you are using your calculator that you're being smart about it. You're realizing what's in the restriction and where your reference angles need to be in what quadrants. Okay, this will take some time, so please practice that in your homework. Last one. So we're going to solve a trigonometric equation that involves a multiple of an angle. So solve the equation sine of 3x equals 1, again on the interval 0 to 2 pi. Well, I need to be kind of smart about this. I know sine of pi over 2 is 1. So if I can get this to kind of match up, then I'm done. Notice if 3x is pi over 2, then they both equal 1, which is the first solution we find. Thus, one solution can be formed by writing 3x equals to pi over 2. Because if I put pi over 2 in there, that will get 1. Well, divide by 3, divide by 3. One possible solution is x equals pi over 6. Now let's look for other solutions. What is another value that 3x could equal so that the sign would be 1? Well, think of your unit circle right here. I need it to be right here. This is where the sign is 1. So 1 rotation is pi over 2. Let's go around again. That would make it 5 pi over 2. In this case, divide by 3, divide by 3. X would equal 5 pi over 6. So far these are my answers. Now I need to go all the way to 2 pi so I can keep going. My x's have to get all the way to 2 pi. Well, let's do another rotation on my unit circle. 3x could equal 9 pi over 2. Because 9 pi over 2, sine of 9 pi over 2 is 1. So it's another rotation on my unit circle. So x in this case would be 3 pi over 2. Okay, I'm getting there. Getting closer to 2 pi. I'm not there yet, so let's do another rotation. 3x could also equal 13 pi over 2. Well, when I do this division, x actually equals 13 pi over 6. Now this is out of the restriction. I can only go to 2 pi. This is bigger than 2 pi. So, not possible. You can kind of write outside interval or outside restriction. So that shows me that these are my only 3 possible answers. Okay, you keep going until x is out of the interval of 2 pi. Please practice these as well. Again, all about unit circle. Good luck.